Okay, now let us discuss the second case, that is effect of potential. In the first case, we have discussed about effect of intensity on photoelectric current. Now, in second case, we will discuss about effect of potential. Now, effect of potential. For effect of potential, what Leonard and Horwitz did, that they take different intensities. They took different intensities and frequency was constant. Frequency was constant, right? For understanding the concept of effect of potential, what Leonard did, they took different intensities of light. That means the intensity, I have already told you that whenever the word intensity will come, so you have to think of the power, right? So this may be 100 watt, 200 watt, 300 watt, right? And I3 is greater than I2 than I1, that means this is a greater intensity, this is lower, this is the lowest intensity. और दूसरी चीज उन्होंने क्या किया, जो फ्रीक्वेंसी थी, फ्रीक्वेंसी को कांस्टेंट रखा. अब जब हम इफेक्ट ऑफ पोटेंशियल को पढ़ते हैं, इफेक्ट ऑफ पोटेंशियल को पढ़ने के लिए जस्ट रिकॉल द लेनार्ड एक्सपेरिमेंट जो हमने पिछली वीडियो में पढ़ा था. उसमें हमने क्या पढ़ा था, हमने दो पोटेंशियल के बारे में बात करी थी. पहले जब हमने पॉजिटिव पोटेंशियल रखा था, तो पॉजिटिव पोटेंशियल रखने पे क्या हुआ, कुछ टाइम के बाद फोटोइलेक्ट्रिक करंट क्या हो गया था, कांस्टेंट, इट बिकम्स कांस्टेंट. फिर उसके बाद हमने नेगेटिव पोटेंशियल रखा. नेगेटिव पोटेंशियल रखने के बाद the photoelectric current gradually decreases, and after some time what happened, it becomes zero, and that particular potential we called it as stopping potential. So in this case the same, you can recall the Leonard experiment. अब उसी हिसाब से उन्होंने क्या किया, ग्राफ को ड्रॉ किया. ग्राफ को ड्रॉ करते वक्त उन्होंने क्या किया, जैसे पहले केस में इफेक्ट ऑफ इंटेंसिटी विदाउट अप्लाइंग एनी एक्सटर्नल AC source or external potential, there was some flow of photoelectric current because of the particular frequency of light incident on the photosensitive plate, and it starts emitting the electron, and because of the emission of electron, the photoelectric current starts flowing. And up to that, this is the photoelectric current value when there is no potential is applied. Okay, now potential is applied. As soon as the potential, positive potential is applied, what happened? The flow of electrons that gain the energy and it start increasing. अब वो बढ़ने लगा. So you can see the graph. It is increasing, and after some time it becomes constant. Gradually it increases, and after some time it becomes constant. Same for this intensity, as the intensity is more than this, so the initial photoelectric current will be more. Getting my point? जब उसकी इंटेंसिटी पहली वाली इंटेंसिटी से ज्यादा होगी, तो उसके अंदर more capacity will be there to eject more photoelectrons. More photoelectrons, more photoelectric current will flow. So for this intensity, the initial photoelectric current is this. Then gradually it increases, and after some time it becomes constant. Same for I3, also it increases and then becomes constant. So this is the saturation current which I am talking about, which becomes constant after some time. Now when the negative potential is applied, तो क्या हो रहा था, जो photoelectric current है वो gradually decrease हो रहा था. Decrease होने के बाद कुछ टाइम के बाद क्या हुआ, वो zero हो गया. So when the negative potential is applied, this side is negative potential, this is negative potential. Okay, so negative potential is applied, so the amount of current decreases, and after some time it becomes zero. For I2 also it decreases, and after some time it becomes zero, and for I3 also it gradually decreases, and after some time becomes zero. And the potential at which the photoelectric current becomes zero, when a negative potential is applied, that potential is known as stopping potential. That potential is known as stopping potential. अब यहाँ पे एक बात ये समझनी बहुत जरूरी है कि देखिए तीनों इंटेंसिटी पे स्टॉपिंग पोटेंशियल क्या है, सेम है, तीनों इंटेंसिटी पे स्टॉपिंग पोटेंशियल क्या आपका सेम है। इसका मतलब ये हुआ कि जो आपका स्टॉपिंग पोटेंशियल है दैट डज नॉट डिपेंड अपॉन द इंटेंसिटी ऑफ द लाइट। अगर आपकी फ्रीक्वेंसी कांस्टेंट है, मतलब आप एक सिंगल मोनोक्रोमेटिक सोर्स यूज कर रहे हो, क्या यूज कर रहे हैं, सिंगल मोनोक्रोमेटिक सोर्स, क्योंकि फ्रीक्वेंसी की जब बात आएगी तो फ्रीक्वेंसी के लिए मैंने आपको बताया था कि आपको क्या ध्यान रखना है, कलर की बात, ठीक है। तो मोनोक्रोमेटिक सोर्स अगर आप यूज कर रहे हैं, बेशक उसकी फ्रीक्वेंसी क्या है, अलग अलग है, फ्रीक्वेंसी बेशक उसकी क्या है, अलग अलग है, लेकिन उसका स्टॉपिंग पोटेंशियल क्या होगा, सेम। उसका स्टॉपिंग पोटेंशियल क्या होगा, सेम। सो स्टॉपिंग पोटेंशियल डज नॉट, वेरी इंपॉर्टेंट पॉइंट, स्टॉपिंग पोटेंशियल डज नॉट डिपेंड अपॉन इंटेंसिटी। Stopping potential does not depend upon intensity of light. It depends upon the frequency of light. Right? That means frequency and stopping potential, they are interrelated. Later we will discuss how they are interrelated. Then how the photoelectric current, stopping potential depends upon the frequency. Right? So right now, from this experiment they explain that intensity depends upon the electric current. क्या चेंज हो रहा था, इंटेंसिटी बढ़ी, फोटो इलेक्ट्रिक करंट बढ़ गया, इंटेंसिटी बढ़ी, फोटो इलेक्ट्रिक करंट बढ़ गया। तो इंटेंसिटी जो उन्होंने पहले उससे भी ग्राफ से एक्सप्लेन किया था कि इंटेंसिटी इज डायरेक्टली प्रोपोर्शनल टू फोटो इलेक्ट्रिक करंट। हियर आल्सो इट इज एक्सप्लेन्ड, getting my point, here also it is explained, but from here one more thing we got that stopping potential does not depend upon the intensity, it depends upon the frequency of the light. So if the frequency is constant, as in this case, so stopping potential is also constant, same for all intensities. So this is the effect of potential, right? Third case is the effect of frequency of incident radiation. Effect of frequency of incident radiation. Right? In that case also, that is very important. Effect of frequency. That means we are now using source of different color. Effect of frequency, that means frequency will remain changed, intensity will remain same. So in this what we will do, we will change the frequency, fix intensity. We will see कि after changing we will see the effect of change of frequency through graph, right? So in this case we found that the graph which we obtained is slightly this way. Okay, so this is the graph which we got with the help of effect of frequency. Now you can see in this graph, when the intensity is fixed, intensity is constant. Intensity is constant. So for the same intensity, the stopping potential, this V0, V01, V02 and V03 are the stopping potential. They are stopping potential. Right? So from here you can see that when the intensity of the light or the source is constant, that means we are using different color of source, but their intensity is एक आपका सोर्स येलो कलर का है, इससे लाइट इमिट हो रही है 100 वॉट की, ठीक है। एक दूसरा सोर्स है आपके पास ब्लू कलर का, इससे इंटेंसिटी रिलीज हो रही है 100 वॉट की। इंटेंसिटी सेम है, लेकिन हम क्या कर रहे हैं, कलर चेंज कर रहे हैं। अब आपको पता है विक्योर के हिसाब से, अकॉर्डिंग टू दिस इज द लीस्ट फ्रीक्वेंसी, दिस इज द हाईएस्ट फ्रीक्वेंसी। तो ब्लू एंड येलो अगर हमने दो सोर्स ले लिए, तो ब्लू, येलो और ग्रीन हमने लिए फॉर एग्जांपल, ये तीनों हमने लिए। सो फ्रीक्वेंसी विल बी दिस, विल हैव mu3, दिस इज mu2 एंड दिस इज mu1, mu1, mu2 and mu3, right? Because frequency of blue is greater than frequency of yellow. So through this they observed that when the intensity of light is fixed, so for different frequency of light, the stopping potential is also different, right? The stopping potential is also different. And when it was constructed for stopping potential and frequency relation, so it was found that stopping potential varies linearly with the frequency of incident radiation. So they concluded that if we draw with respect to frequency and potential, frequency and stopping potential, it was found that the frequency and stopping potential, they vary linearly. Now why this graph is not from origin? That is the question. Why this graph is not from the origin? So the answer to it is that electron emits out after they obtain a threshold frequency. Right? So till here, this is the value of frequency, this is the value of stopping potential. Till here, the particular metal, आप फ्रीक्वेंसी को दे रहे हैं, आपने इंसिडेंट कर दी रेडिएशन इंसिडेंट करने के बाद, इंसिडेंट रेडिएशन, जो रेडिएशन आपने किया वो इंसिडेंट होने के बाद, इट इज नॉट नेसेसरी कि इमीडिएटली क्या हो, इलेक्ट्रॉन्स एमिट हो जाए, इट इज नॉट पॉसिबल। Electron emits out only when a particular frequency, minimum amount of frequency required by a metal surface, that is threshold frequency. This value is the threshold frequency. This value is the threshold frequency. जब तक ये अटेन नहीं होगी तब तक मेटल सरफेस से इलेक्ट्रॉन एमिट नहीं होगा. So this basically is the threshold frequency and stopping potential and frequency. They are for linearly variable, and if we draw for two different metal, so it will be different for different metal. If this is metal A and this is metal B, आपको पता है सेम एक मेटल का कभी भी सेम थ्रेशोल्ड फ्रीक्वेंसी नहीं हो सकती. So it means that for different metals the threshold frequency is different for different metals. Clear? So these are three basic observations from the Lenard experiment which they did, and this is the relation between stopping potential and frequency that varies linearly. Okay, so you have got two different concepts now. Now from the equation you know half mv square equals to EV naught equals to h mu, because mu and frequency they are what? Directly proportional. So that means frequency and kinetic energy is also directly proportional. Frequency and kinetic energy is also directly proportional, which means that kinetic energy is independent of intensity. Kinetic energy is also independent because stopping potential is independent of intensity, frequency is independent of intensity. Therefore, the kinetic energy is also independent of intensity. Only photoelectric current depends upon the intensity. This is very important point. I am repeating. You have learned four things over here. Okay, four things over here. One is your intensity, photoelectric current, then stopping potential, then frequency, and last kinetic energy. Okay, so 1, 2, 3, 4, 5 things you studied through these graphs. Now the relation between them. Now these two are interrelated. Intensity and photoelectric current, from the first observation we conclude that they are interrelated. Okay, आपस में वो directly proportional, linearly increase decrease करते हैं. But this intensity depends only on photoelectric current. Stopping potential does not depend upon intensity, no. Frequency does not depend upon intensity, no. Kinetic energy does not depend upon intensity. ठीक है? उसके बाद frequency and stopping potential, they are linearly variable, so as the kinetic energy also. ठीक है? तो जितना ज्यादा आपका नेगेटिव पोटेंशियल बढ़ता रहेगा, काइनेटिक एनर्जी ऑफ द इलेक्ट्रॉन्स भी क्या होगी, बढ़ती चली जाएगी. ठीक है? सो दिस इज ऑल अबाउट, दिस इज वेरी इंपॉर्टेंट, बिकॉज ग्राफ से ही आपका जो है क्वेश्चन मैक्सिमम आते हैं. इस चैप्टर से ग्राफ से ही क्वेश्चन आएंगे. राइट? सो प्लीज गो थ्रू दीज ग्राफ्स. नेक्स्ट वी विल डिस्कस अबाउट लॉज ऑफ फोटोइलेक्ट्रिक इमिशन. Laws of photoelectric emission we will discuss. So read it thoroughly, see the video repeatedly in order to get your doubts clear. Okay, that's all. Thank you so much.